Hello everyone. So let's solve today's Leetcode daily challenge question. So filling bookcase shelves. So you are given an array of books where books of I is equal to thickness of I comma height of and indicates the thickness and height of the ith book. And also we are given with the shelf width. We want to place these books in order onto bookcase shelves that have a total width shelf width. Okay. So we are given a integer shelf width. This is a width of a shelf, and we want to place our books into that shelf. Okay. So we choose some of the books to place on this shelf such that the sum of their thickness is less than or equal to shelf width. Then build another level of shelf of the bookcase so that the total height of bookcase has increased by the maximum height of the books we just put down. Okay. And we repeat this process until there are no more books to place. Okay. So if we see an example, we are given seven books. Okay. Seven books. And there's one more condition that, oh yeah, so the minimum possible, okay, what we have to return the minimum possible height that the total bookshelf can be after placing shelves in this manner. Okay, so again, yeah, here this note. So at each step of the above process, the order of books we place is the same order as the given sequence of books. So we have to place the books as per the order only. So here you can see 1, 2, 3, 4, 5, 6, 7. Okay, so in the same order we have to place. So if we see this example, okay, yeah, so yeah. So this is our example. So first is one, this first element is thickness and second is the height of this book. Okay, so they have placed first book on the first shelf and second book on the second shelf, third on the third, third on the second. Again, 4, 5, 6, and 7th are placed in third shell. So total height is this is 1. This the height of this is 3. Then 1 plus 3 is 4. 4 plus this the maximum height. So we know for height of fourth book is 1, fifth is 1, sixth is 1, but height of seventh is 2, right? So we have to take the maximum because we have to consider the shelf height, not the book height. Okay, not a individual book height. So this self shell height is 2. So 2 plus 3 plus 1 is total how much? 6. So in this way they have placed. Again, if you see this book 1, 3, 2, 4, 3, 2, then how it will be placed? So if I take pen, yeah. So here 1, 3. So 1 is the thickness, and what is we are given with the shelf width as a 4, right? Maximum. So here you can see shelf width is 4. So as to we can place 2 here also, but the we have to return minimum possible height that total bookshelf can need. Okay, so here they have optimized. So first let's see this example. So 1, 3, and our maximum what is shelf width is 6. So we have 6. Okay, we this is first, then 2, 3, 4, 5. We are given a width. Okay, so maximum how much we can place it in 6. Yeah, 6. Where is it? 6. Okay. Now what is our problem? This, right? So we'll be given a 2D array. Okay, let's increase the font so that you can see it. Yeah. So 1 3. So the first book is of thickness 1 and height of 3. So we can place here height of 3. So here this, and okay, now we can place, so this is 1 unit, 2 unit, 3 unit. So this is one book which has width 1 and height 3. Again, this second book has 2 as its width and height as 4. So can we do like this? Okay, so its width is 2, height is 4. And for the third book, we have its thickness is 3 and height is 2. So here all we have to check first that width. We know how much width is, I mean, there is 6. Okay, given we are given with the 6 as a maximum. So if here, if this book has width as a 4, then can we place here? No. So we have to place after this. Yeah, okay. In the next, this is one shell. Okay, but here we have the number which we can place in this cell. So 3 and 2. Height is 2 and width is 2. Width is 3. Then what we have to return? We have to return the maximum height. What is the maximum height? This is 4. Okay. So here you can see output is our 4. So same way here they have placed. Okay, let's see this example once, then it is more clear. Okay, we have our shelf width as a 4. Okay, shelf width as a 4, and I'm just okay. Yeah. Okay, so what is our question? Yeah, this. Okay, now the first book has thickness 1 and height is also 1. Okay, so we can place here. For the second book, as in the question it is mentioned that we have to place these books as the order it is given. Okay, now that's it is why we are going in this way. So the second book we have is 2 and 3. 2 is the thickness, 3 is the height. So can we place 2 here? Yeah, so we have 2 and 3 is the height. So for better understanding, I am drawing this internal lines also. This is second book. Again, third book. Third book has width as a 2 and height as a 3. Can we place here? No. So we have to go to the second shell. So consider this as a second shell. This was the first shell. And we'll consider this is a second shell. Okay. So here can we place this 2 and 3? Yeah. Wait. Width as a 2, height as a 3. And again we have one, we can place it here. One more one, then we can place it here. Then this shelf is occupied. Next we have to go to the next shelf. So we are remained with 1 2 1 1 and 1 2. So we'll be having this 1 1 and 1 2. So 1 is a thickness and 2 is a height. So like this. So what will be our total number, total height? This will be this as a 3, and this 3 6 7 8. So we are getting 8. But the thing is we have to return minimum number. Okay, what is given in the question is we have to return the minimum possible height that the total bookshelf can be uh, placed. Okay, so instead of placing this 2 here, can we place, okay, instead of placing this second book here, can we place here, and then next book as here, and then we have remained with 4 ones, that is this is one here, another one here, the next one, and we are remained with 2 as a height and 1 as a thickness. So what is our height? So 1 plus 3 plus 1 is 4. And wait, 1 plus 3 is 4. 4 plus this maximum height is 2. So total is 6. So that is why it is returning 6. So how we can solve this problem is, how do we know that we have to place this book in the first shell or the next shell, or the current shell or the next shell? Okay, so there is a possibility, right? So when we get possibility that either we have to choose this or this, okay, then we can think about the recursion. Okay, whenever there is a options or choices which we have to make, that time recursion we can apply here, and resulting, if we if you want to optimize, and then we can move to memoization and dp if it is possible. But recursion we can implement here. Okay, so what choices we have? We have choices that we can place a book in the current shell or in the next shell. Okay, so we have two choices. If we are placing in the current shelf, so in previous approach we have seen that this book was placed here in the first shell only. Okay, so but that was not a optimal that was not a optimal solution for our question, right? So it was returning something like 8 as an answer, the height as 8. But what is optimal, or what is a minimum number possible height which we are returning is 6. So we have to check all the cases, that is why we have to use the recursion. Okay, so what choices we have? Book can be placed in the current shell, I guess, shelf, sorry, yeah, or book can be placed, wait, where it is going, yeah, book can be placed in the next shelf. Okay, so we have two choices. So while going to the recursion approach, we have to consider these things, these choices, and one most important thing is the base class. So we are moving from first to the last. Okay, so what will be our base class when we reach this, I mean when we complete our all books to shelf? Okay, when we put our all books to shelf, that means we are done with our solution. Okay, we are done with our work basically. Yeah, so here our base condition will be, if our index whatever we are traversing is, for instance idx is equal to n. Okay, then we will return. So let's try a recursion approach. Okay, then we will move forward to change, or we will update this recursion code to the memoization. So let's take one more method, recursion approach. Okay, here first what we have to pass, we have to pass our book array. Okay, then what we have to pass, we have to pass our index. Then what we need? We need this shelf width. Okay. Now, okay. Now what we need? We need our current width. So we need current width. This is the shelf width. That means maximum. Here maximum is 4. Here maximum is here it is 4. Yeah. Here it is 6. So it will be given in the question. So we'll be passing the same. Now we need a current width. So current width will be for this shelf. The current width is 1, right? And while before placing this book, we will check with the current width and maximum width. We'll add current width plus this is less than maximum width. That means we can place this book in the first shelf only. Okay. So where else? Yeah, we need a current width. Again, we need height. Yeah, we need height because we are calculating height, right? Now, what is our base condition? Base condition is if IDX index is equal to what length? Books dot length. Then it will return height. Okay. Now we have two choices. One is place the book in current shelf. Okay, so for that, and next is place the book in next shelf. So to place the book in the next shelf, if we call the same recursion, okay, we have to call this, right? Now number of choices are basically a number of recursive calls. So what first we have to pass the books array. Then index will be, we will be incrementing 1 because we are placing this 2. That means we will move forward to the next 3, right? Comma, same shelf width. Okay. Now what will be our current width? Our current width will be, as we are placing this book into the next shelf, that means the next shelf is new one, right? So new one, in new shelf only one book is present which we are placing, so the current width will be width of that book. So width that means thickness. Okay, books of I thickness is at 0th, right? So we have, yeah, this is thickness and height. So we have passed the same book width. Again, what will be the height? What height we have to pass? Height will be um, current height. Okay, and okay, so for this two, hmm, for this two, what is its height is 3. So it's current height. So books of I and 1. But what is this? Okay, what is this? What is this? We for the next shelf, but it is returning height, right? So we are returning our total height. So what will be our total height? This shelf, okay, this shelf's height plus above height. Okay, so we will add here our height variable which we are passing. Okay, initially it will be 0. Now if I consider this as a case 2, because we want to, what we want to do is we want to minimize, right? So we have two cases, so we have to check which case has the minimum number. Okay, so that is why here in case 2 I have taken case 2 as a place a book in the next shelf. For the next shelf, we have to consider the current width as its own width, current height as its own height, and add the previous height so that it will return the total height. Okay, this is case 2. Now for case 1, we need to put some condition. What will be the condition? That our current width plus the width of this current book. So width of this current book will be the thickness. It should be less than or equal to what? Shelf width. Okay, then only we can place our book here. So the current width plus the book which we are gonna place, if it fits, we are checking just that our book fits in the current shelf or not. Okay, if it satisfies, then this will be case 1. Okay, case 1. Uh, Same thing we will do. We will call the recursion app. Okay, we'll pass first books. Again, this will be same index plus 1 and this shelf width. Now what is our current width? Current width will be this, right? Because we have placed our book. Case 1 is we are placing our book in the current shelf. So the width will be current width plus books. Okay, this should be previous width actually. I mean, current shelf width basically. Okay, now this is width. Now what we will put for the height will be maximum. Here you can check for this, we it has same height. Here you can check which we take maximum height, right? So mat dot max height, what height? Our current height, what books of I, it's 1. Okay, this height and what? Previous height. We will take this maximum. Yeah, we have to take the maximum height. Okay, because we need a minimum, but in this current shelf, maximum height will be the book of maximum height of the book. Okay, so we cannot take one here, right? We have to take two overall, for overall. Okay, so these are two cases. Now we have to return, what we have to return? We have to return minimum. So mat dot min in the both cases, which output will give me minimum. Okay, so case 1 comma case 2, so this will give us minimum. Okay, now let's call this here, where we are passing books. Then index will be 0 initially, shelf width will be the same, and current width, height will be same. Yeah, current width and height is, I mean, 0. Okay, so we will return this only. So let's check. So we are getting some compilation error that there is no I. Okay, yeah, so I used I, so instead take I only, because so many changes we have to do then. Still cannot find the symbol height. Wait, what error we are getting? So at some places I have used the IDX, and okay, I'll just change. Okay, this is height. Again I, case 1, here it should be I, then I. Okay, height, then here it will be I. Yeah, now it should work. So if we set a variable, cannot wait. Yeah. So case 1 we have to declare it out, alright. Okay. So let's take, we have to take minimum, right? So instead of directly declaring here, I mean, using here, we can declare it with integer dot max value, because we are taking the minimum, right? So we'll take the like this. dot max value. Okay, so let's run now. I hope so it should work. Yeah, you can see accepted. But the thing is, if we see, this is a I mean, recursion is like, we will call for each call, there can be like same thing we have to calculate again. Okay, so that is why we have to optimize this approach by memoizing it. Okay, so let's do memoization. So in memoization, what we will do, we will memoize our index and its width. Okay, so let's take an array, okay, 2D array, and let's here initialize it. Memo equal to new int. It will be in n plus, that is books dot length plus 1, and width, we are shelf width plus 1. Okay, so we are memoizing both because for each index and its and for that width. Okay, that means what it represents is, let's say, memo of this index and its shelf width. So for that, till that index and the width, okay, how much is the minimum height it represents. Okay, so here, Hmm. Now we have declared it. Now what we have to do? We have to update it, right? So here case 1, case 2. So here only memo of I. Okay, I. And what is width? Width is current width. It's current width. Yeah, which will be equal to this. Now before here, here only we have to check if our, so instead take integers so that we can check the null values also. Otherwise, we can fill this all with the minus 1. Okay, so we'll check here with if our memo of I and current width, which is, if it is null, okay, if it is not null, then we will return what? We will return memo of I, else we it will calculate. Okay, so if there is such equation already exist, wait, okay, if it already exists, then it will not calculate, right? It will directly return. Now this is done. Okay, anyhow we are just okay, unreachable. Wait, here we have used the memoization. So repeated recursive calls will not be called anyhow. Okay, let's try to submit it. So we did the solution, and it got submitted. If we submit the recursion solution, then it will give us a time limit exceeded. So that is why we have to optimize it to memoization method. You can also try with the recursion, then try to convert it to the memoization. Okay, don't directly jump into the DP, because for a better understanding, going with this flow is okay. Yeah. Thank you for watching this video. If you feel this video is very helpful for you, then please like this video and subscribe my channel. Thank you.